Okay, so now let's work out a couple of examples. Now, in both of these examples, we're going to assume that y is defined implicitly by the given equation. Okay, so the first one is the one that we started out with. So we're going to solve this implicitly. Now, keep in mind that it is possible to define and find dy dx and differentiate it implicitly and find and solve it in terms of just variables of x, but usually it's impossible to do that. Okay, so let's start. So first of all, we're going to take the derivative of both sides. So the derivative of x with respect to x is 2x plus the derivative of y squared with respect to x. Remember, this is a function of x, so we're going to use the chain rule. So it's going to be a power rule with y inside. So this is going to be 2y, right? Then we're going to take the derivative of the inside, which is y. So then we're going to have a dy dx here. So there's where the dy dx comes from, using the chain rule with y squared. Because remember, this is an unknown function of x. Okay? So we can't just write 2y. Okay? Now we're going to do the other side, equals, and of course 25 is a constant, so we get 0. And so now what I'm going to do is I'm going to subtract 2x from both sides. And so that's going to give me 2y dy dx equals negative 2x. Now if I divide both sides by 2y, now what do I get? I get dy dx equals negative 2x over 2y. And so what do I get? Dy dx equals negative x over y. Now notice that the derivative with respect to x, the derivative here, is in terms of both x and y. Okay? So we don't know what this function is, right? So this is one of the results of having to deal with implicit differential or implicitly defined equations. Okay? But that's the answer. Okay? Can't do anything more than that. Now let's look at this example here. Now in this example we have a couple of things going on. We have a product and we have another one here, right? So again, I'm going to go through the steps and I'm going to solve for dy dx. Okay? So if I want to, again, we're assuming this is implicitly, this implicitly defines the function y. Okay? So we're going to have to use a product rule here. So it's going to be the derivative of the first times the second plus the derivative of the second. Now here's where y comes in. We're going to have to use the chain rule. So the derivative of the second is going to be negative. It's going to be cosine y times the derivative of the inside function, which is dy dx. Plus, again, we have y, so this is going to be another dy dx. And then equals, now we're going to take the derivative of the second side, which is going to be what? 4. And so now what I'm going to do, I'm going to collect all the terms that have dy dx in them. And then I'm going to put those on one side of the equals sign, and the rest, everything else is going to go on the other side of the equal sign. So what do we have? Well, I'm going to rewrite this as cosine y, so I'm going to put dy dx cosine y plus dy dx equals 4 minus 3x squared sine y. Now I'm going to factor out the dy dx. So I get dy dx times cosine y plus 1 equals 4 minus 3x squared sine y. And now I'm just going to divide both sides by cosine y plus 1, and I'm done. So what do I get? I get dy dx is equal to 4 minus 3x squared sine y, all divided by the quantity cosine y plus 1. And that's where we would stop. And that's it. Notice again that we have y and x both in the expression. Okay. Now, if y could be expressed explicitly, then we could just substitute in for y. But since in this case we can't do it, we just leave it that way. So we just know that y is some unknown function of x. We don't know what it is, so we have to leave it that way. Okay, that's it. Have a great day.